Good morning, everyone. So we'll move to the next method, which is called as the big M method or the chance method of penalty. The other day we have seen simplex method. Simplex method is used when we have objective function as maximization and the constraints are all less than or equal to. So here also we have the same condition, objective function maximization, right hand side of each constraint should be positive, but there is no restriction on the inequality. You can have less than or equal to or greater than or equal to. Okay, that's a drawback of simplex method, that it is not used for the other inequality. So that is why we are having big M method or the chance method of penalty, where we can we can solve an LPP when we have less than or equal to constraint or greater than or equal to constraint or equal to constraint, etc. It can be solved by big M or chance method of penalty. So again, even though we have two different methods, like we can have even for minimization or maximization, but here I'm going to convert every problems to maximization and then solve by the normal method. So I'm not going to explain two different methods. We'll have only one common method, that everywhere the objective function is to be, we should have objective function as a maximization function. So we'll take an example. Again, as I told you, the method will be specified in the problem. So solve by big M method, maximize z equal to 6x1 plus 4x2 subject to 2x1 plus 3x2 less than or equal to 30, 3x1 plus 2x2 less than or equal to 24, x1 plus x2 greater than or equal to 3, and x1 comma x2 greater than or equal to 0. First, we have to see whether the objective function is maximization or not. If it is maximization, we did not convert it. If it is a minimization problem, convert the minimization problem to maximization. So here already it is in the maximization form. Right hand side of each constraint. Now right hand side matlab, these are the right hand side of each constraint. Right hand side of each constraint should be positive. You can have even 0, but you cannot have negative number. Okay. The right hand side of each constraint should be non-negative, and there is no restriction on the inequalities. You can have less than or equal to, you can have greater than or equal to, etc. So now our aim is to reduce this LPP to standard form. Our aim is to reduce this LPP to standard form. Now standard form matlab, we should not have any inequalities. All these inequalities are converted to equalities. Okay, we have to convert these inequalities to equalities. Now how do we convert the first constraint to equality constraint? What do we do? In the simplex method, what did we do there? How did we convert an inequality to equality in simplex method when we had less than or equal to constraint? How did we convert that? By adding what type of variable?
Slack or surplus variable.
Yes, slack variable in the case of less than or equal to, and surplus variable in the case of greater than or equal to constraint. So here first two constraints are less than or equal to. That means we have to add slack variable. Now here greater than or equal to. So left hand side is greater than the right hand side, which means that something has to be subtracted from the left hand side. That is called as a surplus variable. So reducing this LPP to standard form. Objective function is maximization, right hand side is positive. Now we are adding slack variable S1, S2, and we will take the surplus variable as S3. Okay, adding slack variable. Now when we add slack, because we had plus S1, there is something less, left hand side is less than the right hand side. So we have to add something on the left hand side. So this is plus S1, this is plus S2, here we'll get minus S3. See, now when we write the table, do you remember the table? What did we do? X1, X2, all the variables, then we write all the coefficients from the first constraint, second constraint. तो हम जब ऐसा करते हैं, what is the XB column normally? हम लोग एक्स बी कॉलम कैसे लिखते थे सिंप्लेक्स मेथड में, याद है? How did we write that XB column? XB column was corresponding to the unit matrix 1001 या 1000100001. Now, if I subtract from here minus S2, you will not get 100. Even though there are three constraints, we should have 3 by 3 unit matrix when you form the initial table. Okay, when you write all these coefficients in the table, we should have, since there are three constraints, we should have a 3 by 3 unit matrix. लेकिन यहाँ पे क्या हो रहा है, minus S2 आ रहा है, which means that we will not be getting a unit matrix form. So just to get a unit matrix, whenever we subtract a surplus variable, we have to add an artificial variable just to get that 100 form, for no other purpose. Okay, just so that we can follow the same procedure of the simplex method. So what we have to do is, whenever we have greater than or equal to constraint or equal to constraint, we have to add an artificial variable. We have to add an artificial variable just to get 100010001. No other purpose behind that. ठीक है? सो नाउ तो वहां पे हमको एक आर्टिफिशियल वेरिएबल ऐड करना पड़ेगा लेस देन और इक्वल टू, और उसका जो कॉस्ट है, वी गिव द कॉस्ट एज माइनस एम इन द ऑब्जेक्टिव फंक्शन वेयर एम इज वेरी लार्ज. That is why this method is called as the big M method. Okay, so when the objective function is maximization, we give the cost as minus m to this artificial variable, which we are going to add in the third constraint. तो यहाँ पे यही डिफरेंस है कि whenever you are having an equality constraint or a greater than or equal to constraint, then we have to add an artificial variable in order to get this unit matrix in the basic table. That is the only purpose. But we give the cost as minus m, where m is very large. We are subtracting a large amount from the objective function, so that the objective function is again not getting not getting altered. So what we have to do is, so remember, make a note of that. So whenever we have greater than or equal to constraint or equal to constraint, add an artificial variable, and this minus m is given to the objective function, the cost of artificial variable in the objective function. तो नेक्स्ट स्टेप में मैं S1 S2 यहाँ पे माइनस S2 प्लस a आ जाएगा. तो दिस इज द, तो हमारा LPP था, वहां पे मैंने स्लैक वेरिएबल S1 ऐड किया, S2 ऐड किया, वो दोनों का कॉस्ट जीरो पुट, जैसे हमने सिंप्लेक्स मेथड में किया वैसे ही करना है. एडिंग द गिविंग द कॉस्ट एज जीरो टू दीज स्लैक वेरिएबल्स. Then we are subtracting a surplus variable because we had greater than or equal to constraint. उसका भी cost zero देना है. Plus we add an artificial variable. उसका cost minus m. Actually, this minus m is for maximization and plus m is for minimization. But I'm not going to keep the function as minimization because we will have the same procedure. We'll convert all minimization problem to maximization problem. So remember only one thing, minus m is the cost which is given to the artificial variable. Okay, where m is very large. बहुत बड़ी वैल्यू, अगर हमको 100 ले लो, 1000 ले लो, बहुत बड़ी वैल्यू है m की. Okay, this extra concept is there in the big M method. बाकी सब procedure same है जैसा हमने simplex में किया, but here this method is this is the extra part what we have it in big M method. तो प्रोसीजर हमेशा सेम रहेगा, खाली छोटी छोटी चीजें जो ऐड हो जाएंगी, सब्ट्रैक्ट हो जाएंगी, जो भी है उसके हिसाब से हमको सॉल्व करना है. ओके, सो दिस इज द बेसिक थिंग. ठीक है, सो रिमेंबर, आर्टिफिशियल वेरिएबल अगर इक्वालिटी कंस्ट्रेंट है तो भी ऐड करना है, ग्रेटर देन इक्वल टू कंस्ट्रेंट है तो भी ऐड करना है हमको. ओके, उसके बाद हमको टेबल बनाना है, जैसे हमने उस दिन बनाया टेबल वैसे ही टेबल बनाना है. उसके लिए पहले कितने वेरिएबल्स हैं वो चेक करने हैं. सो वी आर हैविंग x1 x2 s1 s2 s3 and artificial variable. So we will write all the variables s2 s3 a, and the right hand side क्या बोलते हैं उसको, how do we denote the right hand side of each constraint? What is the variable we used? किसी को याद है?
मैम BI.
BI. The right hand side of each constraint, we are using the variable as BI. Yes, correct. उसके बाद फर्स्ट कंस्ट्रेंट हमको लेना है, उसमें जो भी कोएफिशिएंट्स हैं ये वेरिएबल्स के, उसको हमें यहाँ पे फर्स्ट रो करके लिखना है. तो फर्स्ट x1 का कोएफिशिएंट इन द फर्स्ट कंस्ट्रेंट इज 2, तो यहाँ पे 2 आ गया. x2 का कंस्ट्रेंट 3, S1 ka 1, S2 is not there in the first constraint, so 0. S3 is also not there in the first constraint, 0. A is also not there, and BI is equal to 30. Okay, just like the same procedure what we have done for the simplex method. Only thing, we have to add an artificial variable and give the cost as minus m, where m is very large. That is why this method is called as the big M method. फिर second constraint लेना है. So 3, 2, S1 is not there, so 0. S2 ka coefficient 1. S3 is not there in the second constraint. A is not there. And then we have 24. Third constraint mein, x1 ka coefficient 1. x2 ka 1. S1 is not there. S2 is not there. S3 is minus 1. A is 1. And then this is equal to 3. Yeah? Hello? Any doubt? If you have any doubt, you can unmute yourself, okay? Division A students, please unmute yourself and ask if you have any doubt. Huh. I didn't get the question. What is that? Yes. सभी इक्वेशंस मतलब सी अगर गिवन प्रॉब्लम में ग्रेटर देन और इक्वल टू का कंस्ट्रेंट आता है तो हमें ए ऐड करना ही पड़ेगा. ठीक है, इक्वल टू कंस्ट्रेंट आता है तो भी हमको ए ऐड करना है. दैट वे यू रिमेंबर. ठीक है, तो बिग एम मेथड नॉर्मली तो स्पेसिफाइड रहेगा मेथड सॉल्व करने को, लेकिन नहीं भी किया है तो अगर ग्रेटर देन और इक्वल टू कंस्ट्रेंट है तो we cannot add a slack variable. We have to subtract a surplus variable. So when you subtract a surplus variable, we have to add an artificial variable just to get the 0, 0, 1 in the table. ठीक है? And I'll tell you what is to be done with artificial variable later on. तो सबसे पहले हमको वो just इनिशियल जो टेबल हमको बनाना है उसके लिए वी हैव टू मेक यूज ऑफ दिस आर्टिफिशियल वेरिएबल. ओके, तो पहले हमने कंस्ट्रेंट्स में से ये सब लिख लिया. नाउ राइट द कोएफिशिएंट्स फ्रॉम द ऑब्जेक्टिव फंक्शन. नाउ व्हाट आर दीज कॉस्ट कोएफिशिएंट्स डिनोटेड बाय, उसको क्या बोलते हैं हम लोग? हाउ डू वी राइट दिस कॉस्ट कोएफिशिएंट 6, 4, उसको क्या बोलते हैं हम लोग?
CJ.
CJ. It is called as CJ. So we will write CJ. तो CJ में again x1 का कोएफिशिएंट 6, x2 का कोएफिशिएंट 4, s1 का 0, s2 का 0, s3 का 0 and a का minus है. ठीक है, procedure remains the same. Once you get this artificial variable, then everything is same. Only thing, the cost is equal to minus m because we want to get rid of that artificial variable. We are just adding a variable so that we can have the same procedure as the simplex method. Only for that purpose we are adding. Then अभी यहाँ पे आएगा xb column. Now tell me which variables are there in the xb column. तो हमें क्या चेक करना है, एक बार ये सब लिखने के बाद देखो 1 0 0 0 1 0. Why? There are three constraints. There are three constraints given in the problem. So we should have a 3 by 3 unit matrix. We should have a 3 by 3 unit matrix. तो यहाँ पे 3 by 3 unit matrix किसके नीचे आ रहा है? एक S1 के नीचे आ रहा है, एक S2 के नीचे आ रहा है और A के नीचे आ रहा है. S3 is not having a plus 1. S3 is not having plus 1. हमें यूनिट मैट्रिक्स देखना है तो 1 0 0 0 1 0 0 0 1 is corresponding to A. Only for that purpose, otherwise we won't be able to get 3 by 3 unit matrix. अगर हमने S3 रखा ना तो हम लोग को 3 by 3 unit matrix यहाँ पे -1 हो जाता है. That is why we will have S1, S2 and A. ठीक है, now it is clear why are we adding artificial variables, so that we can write this XB column. नहीं तो हमारे पास रहेगा ही नहीं. Only for that purpose, that is why it's called as artificial. You're going to just add a variable which has to be deleted once it goes out of the basis. तो यहाँ पे now variables will be 1 0 0 S1 के नीचे है तो S1 आ जाएगा, 0 1 0 S2 के नीचे है तो S2 we will write, and then 0 0 1 is below the A column. Clear this part? So many of you told S1 S2 S3. ठीक है, हर्ष निकिता एंड ऑल. ओके, सो हमें क्या करना है, यूनिट मैट्रिक्स देखना है. जितने भी कंस्ट्रेंट्स हैं उसके हिसाब से, अगर 3 कंस्ट्रेंट्स हैं तो 3x3 यूनिट मैट्रिक्स होना चाहिए. ओके, अगर 2 कंस्ट्रेंट है तो 2x2 यूनिट मैट्रिक्स होना चाहिए. तो यहाँ पे 3x3 लाने के लिए पहला S1 आ गया, फिर S2 आ गया, फिर A वाला आ गया. नेक्स्ट इज वी राइट CB. CB इज द कॉस्ट ऑफ दीज वेरिएबल्स. तो S1 के ऊपर हमने लिखा है 0, तो यहाँ पे 0 आ जाएगा. S2 के ऊपर लिखा है 0, तो यहाँ पे भी 0. A के ऊपर लिखा है -m. ठीक है, ये वाला पार्ट हो गया. उसके बाद क्या निकालते हैं हम लोग, पहले हमने सब वेरिएबल्स लिखे, फिर CJ लिखा, फिर XB लिखा, फिर CB. यस, नेक्स्ट वी हैव टू कैलकुलेट इज ZJ. नाउ ZJ हम कैसे निकालते हैं, ZJ is calculated for each column. That means CB into XI. 0 into 2 plus 0 into 3 plus minus M into 1. हर एक कॉलम को CB से मल्टीप्लाई करना है, यहाँ पे समेशन लिखना है. तो 0 into 2 plus 0 into 3 plus minus M into 1. तो ये हो जाएगा -m. बाकी दो 0 है. फिर सेकेंड कॉलम का लिखना है, 0 into 3 plus 0 into 2 plus minus m into 1. Again it is equal to -m. फिर 0 into 1 0, 0 into 0 minus m into 0, that is again 0. Then 0 into 1 0 0, then 0, again this is 0. Then 0 0 minus m into -1 will become m. Then 0 0 and this will become -m. ठीक है, सेम प्रोसीजर हम लोग फॉलो कर, यहाँ पे खाली m वेरिएबल आ जाता है तो थोड़ा सा कॉम्प्लिकेशन होगा, बिकॉज व्हेन यू स्टार्ट यूजिंग द रो ट्रांसफॉर्मेशन m की वजह थोड़ा सा कैलकुलेशन ज्यादा हो जाएगा, अदरवाइज एवरीथिंग इज सेम. नेक्स्ट वी हैव टू कैलकुलेट ZJ minus CJ. Next we have to calculate ZJ minus CJ. So ZJ is -m, CJ is 6 for this particular column. So we will have -m minus 6. For second column, -m minus 4. 0 minus 0, 0 minus 0, m minus 0, m, minus of -m, that becomes 0. तो और एक चीज चेक करना है यहाँ पे, I forgot to tell you, अगर हमारे ये बेसिस है S1 S2 A, तो ये जो वेरिएबल्स का जो कॉलम है उसके नीचे ZJ माइनस CJ सब 0 आना ही चाहिए. ओके, जितने भी वेरिएबल्स यहाँ पे हैं उसके नीचे जो ZJ माइनस CJ का जो रो है वहां पे सब एलिमेंट्स S1 का 0 आ गया, S2 का 0 आ गया, A का 0 आ गया, आना ही चाहिए. We have to get ZJ minus CJs are 0 for these variables which are there in the basis or in the XB column. ठीक है, हाँ, अभी ये टेबल हो गया. उसके बाद हमको क्या चूज करना होता है, की कॉलम. How do we choose the key column? Key column is chosen by using the most negative number. Without the negative sign, whichever is the highest number, that is taken as the most negative. Now here m is there. तो I told you m is very large. अगर मैंने m को 100 दे दिया, सपोज m को 100 दे दिया, तो ये कितना हो जाएगा, -100 -6, तो -106, यहाँ पे हो जाएगा -104, और यहाँ पे हो जाएगा 100. So which one is the most negative number here, first or second? m minus 6, बिकॉज अगर मैंने m को 100 लिया, m इज अ वेरी लार्ज वैल्यू, अगर मैंने m को 100 लिया तो ये हो जाएगा -100 minus 6 which is -106, और ये हो जाएगा -104. So without negative sign, whichever is the greater number, that will become the key column. So the first column will become the key column. ठीक है, अभी की कॉलम, तो की कॉलम में कितने एलिमेंट्स हैं? एक 2 है, एक 3 है, एक 1 है ना. 2 3 1, ऑल द 3 आर पॉजिटिव. अगर यहाँ पे कोई भी नेगेटिव है, 0 है, तो उसका रेशियो नहीं लेना है. तो नेक्स्ट वी हैव टू कैलकुलेट द रेशियो. Ratios are taken only for the positive numbers in the key column. If you have any negative number or 0, then the ratios are not considered. So यहाँ पे all the 3 are positive. So I can write the ratio as 30 by 2, that is 15, 24 by 3, that is 8, and 3 by 1 is equal to 3. BIs upon the corresponding positive elements in the key column. BI divided by जितने पॉजिटिव नंबर्स हैं, ये BI 30 अपॉन पॉजिटिव नंबर इज 2, तो 30 अपॉन 2, 24 अपॉन पॉजिटिव नंबर है 3, तो 24 अपॉन 3, then similarly 3 upon 1. Now how do, which is the key row now? How do we choose the key row? The minimum or minimum ratio, whichever ratio is minimum, that row will become the key row. ओके, तो 15, 8 और 3 में जो भी मिनिमम वैल्यू है, तो वी नो दैट 3 इज द मिनिमम वैल्यू, सो द थर्ड रो विल बिकम द की रो. द थर्ड रो विल बिकम द की रो. The intersection of key row and the key element will be called, key row and key column will be called as the key element. The intersection of key row and key column, मतलब ये जो element है ये हमारा हो जाएगा key element. Okay, so this is the key element. Now here the key element is equal to 1. If it was not equal to 1, then you divide the entire row by that particular to make the key element equal to 1. तो यहाँ पे already equal to 1 है. Okay, अभी हमें क्या करना है? Next step में you don't take the CJ row, don't take the CB, even ZJ can be removed, ratio can also be removed. ठीक है, तो यहाँ तक सबका हो गया? Any doubt till here? Procedure is the same. Whatever we have followed for simplex method, the same procedure we have to follow. Make the key element 1, the remaining elements in the key column equal to 0. Everything is the same. यहाँ तक हो गया, so that I can go to the next table. नेक्स्ट टेबल में हम क्या करेंगे? सीजे नहीं लिखेंगे, सीबी नहीं लिखेंगे, जेडजे भी कैंसिल कर देंगे, रेशियो वाला पार्ट भी. बाकी के सब टेबल्स को हम लोग कंबाइन करके एक जगह लिख देंगे. So once you cancel out all these things, you will get this as the table. चेक कर लो, ऑलरेडी मैंने सीजे वाला रो कैंसिल किया है, सीबी वाला कॉलम कैंसिल किया है, जेडजे कैंसिल किया है, रेशियो कैंसिल किया है. तो वी विल हैव दिस एज द टेबल. जो टेबल हमारा फर्स्ट स्लाइड में था वही हमने यहाँ पे एक बार लिख दिया है. Now key element is already equal to 1. Now make the remaining elements in the key column equal to 0. इसको 0 करना है, इसको 0 करना है और इसको 0 करना है. So what are the row transformation? Using this element 1, make these 3 elements in the key column equal to 0. So what are the row transformations? अगर मैंने 2 को 0 करना है ये 1 यूज करके, तो क्या करेंगे हम लोग? 2 minus 2 करना है ना. अगर 2 minus 2 किया तो 0 आ जाएगा. तो I will write R1 minus 2R3. ओके, 2 minus 2 है तो R1 2 R1 में है, 1 is in R3. So R1 minus 2R3, that is the first transformation. अगर मुझे इसको 0 करना है तो इसको 3 से मल्टीप्लाई करना पड़ेगा और सब्ट्रैक्ट. So I will get R2 minus 3R3, yes. And इसको 0 करना है तो I'll take it as R4 plus M plus 6 into R3. So I have written all the 3 transformations. Third row will not change, that will remain as it is. Other two rows will change now. Other three rows will change. R1 row, R2 row, and R4 row will change. So I'll just rewrite the variables again. So this was the third row. I'm writing it as it is. Sorry, I'm writing it as it is. Okay. Now tell me what will be the first row. फर्स्ट रो में मुझे क्या करना है, R1 को चेंज करने के लिए R1 माइनस टू R3. तो R1 में अगर मैंने 2 लिखा, R3 में मैंने 1 लिखा, तो 2 माइनस 2 पहला एलिमेंट हो जाएगा 0. सेकेंड क्या होगा, 3 minus 2, that is equal to 1. Then 1 minus 0, that is 1. Then 0 minus 0, that is 0. 0 plus 2, that is 2. Then 0 minus 2, which is minus 2. 30 minus 6, that is 24. Is it okay? First row. जब मैं R1 लिखूंगी तो R1 के एलिमेंट को लेना है, एंड जहाँ पे R3 है वहां पे R3 के एलिमेंट को लेना है. तो R1 माइनस टू R3, तो यहाँ पे भी R1 माइनस टू R3, R1 माइनस टू R3. ऐसा करके हमने R1 रो लिखना है. Now tell me what will be the second row. R2 minus 3R3. R2 minus 3R3. पहला एलिमेंट 0. सेकेंड एलिमेंट क्या होगा, -1. ओके. थर्ड एलिमेंट 0 minus 3, that is 0. Fourth element 1 minus 3 into 0, that is again 1. Then 0 minus 3 into -1, that is 3. 0 minus 3, which is -3. And the last element will become 24 minus 3 into 3, that is equal to 50. ठीक है. Okay, next हमको fourth row, we have to use the transformation R4 plus M plus 6 into R3. R4 में आ जाएगा माइनस M माइनस 6 प्लस M plus 6 into R3. तो पहला एलिमेंट तो 0 हो जाएगा. Now what is the second element? माइनस M, R4 के बदले माइनस M माइनस 4 प्लस M plus 6 into 1, कितना होगा, 2. ओके, ठीक है. नेक्स्ट एलिमेंट, this is 0 anyway. This is also 0. What about this number, S3 wala? M plus M plus 6 into -1. -6, yes. -6. और A क्या होगा, M plus 6. नहीं, A has to be M plus 6, right? 0 नहीं होगा ना. Yes, तो ये मुझे चेंज करना है यहाँ पे. 1 second. This is going to be M plus 6. M plus 6. Okay. Now XB column में कौन कौन, we have to at the end of using the row transformation we should have a unit matrix of order 3. Again 1 0 0. 1 0 0 is corresponding to S1. 0 1 0 corresponding to S2. 0 0 1 is corresponding to X1. हमेशा ये 3 वेरिएबल्स के नीचे 1 यूनिट मैट्रिक्स के फॉर्म में होना चाहिए. ओके. लास्ट वन इज HJ minus CJ. नाउ मैंने क्या बोला था, जो भी वेरिएबल्स यहाँ पे हैं वो वेरिएबल्स के नीचे zj माइनस cj में जीरो होना चाहिए. Now we have seen that the artificial variable is not there in this basis. It has gone out. तो ये जो कॉलम है इसको हम डिलीट कर सकते हैं. पहले वाले टेबल में a यहाँ पे था तो हमने उसको यूज किया. Now when we see that a is not there in this xb column, you can just delete. Do not take this column in the next table. Just delete कर. You can just cross that table. Okay? इसको पूरा हम लोग ऐसा क्रॉस कर देंगे. We don't require this. Okay? We don't require this. This is not required in the next step. ठीक है, तो जस्ट कैंसिल दिस. उसके बाद हमको प्रोसीड करना है क्योंकि दिस इज नो मोर इन द बेसिस. आर्टिफिशियल वेरिएबल कैन बी रिमूव फ्रॉम द टेबल. सो नाउ अभी हमें क्या चेक करना है, zj minus cj. Now zj minus cj's, if there are any negative numbers, you have to choose the most negative number. So there is only one negative number, which is minus 6. So this row, S3 column will become the key column. Till you get all zj minus cj's positive, we have to continue the process. लेकिन यहाँ पे फिर भी एक zj minus cj negative है, still we are having. So this column will become the key column. Consider the ratio. In the key column, see for positive numbers. If there are any negative numbers, do not take the ratio. So first one आएगा 24 upon 2, that is equal to 12. 15 upon 3, that is equal to 5. The third element is negative, do not take any ratio. That is going to be dash. ठीक है? Why we are removing? So that we will not have m part in the next. So we can just remove this part. Calculation be easy हो जाएगा. Once this artificial variable is out of the xb column, you can delete that column. So now which one is the key row? Key row is the minimum ratio. Minimum ratio is 5. So the key row is the second row. Second row is the key row. Intersection of key row and key element, key column is called as the key element. So 3 ho jayega key element. 5 is the minimum ratio. So corresponding to that, the second row will become the key row, and the intersection jahan pe key row or key column mil raha hai, that point is called as the key element. So here 3 is the key element. Once you get the key element, your aim is to make the key element 1. And this key element is made 1 only by dividing that particular row. Okay, this key element is made 1 by dividing this row by the key element 3. Do not use any other, ऐसा मत करो कि 3 minus 2 equal to 1. This is made 1 only by dividing this row, the second row by 3. तो अगर मैंने इसको डिवाइड सेकेंड रो बाय 3 तो ये आ जाएगा. बाकी सब सेम है, खाली यहाँ पे 0/3 is 0, -1/3 is -1/3, 0/3 is 0, 1/3 is 1/3, 3/3 is 1, and then 15/3 is 5. तो ये रेशियो वाला पार्ट निकल जाएगा. वी हैव टू डिवाइड द second row by 3 so that we have only this much table now. So this is the key element है ना, ये हमारा key element है. This is the key element now. Now the key element is made 1. Next step will be to make the remaining elements in the key column as 0. जब key element 1 कर दिया तो बाकी जितने भी elements हैं वो column में उसको 0 करना है. मतलब इसको 0 करना है, इसको 0 करना है और इसको 0 करना है by using the row transformation. So key element is made 1 only by dividing the second row by the key element. दूसरा कोई भी ट्रांसफॉर्मेशन यूज नहीं करना है. Any doubt? यहाँ से तो सेम ही है, एक आर्टिफिशियल वेरिएबल का एक्स्ट्रा आ गया था, उसको हमने रिमूव कर दिया बिकॉज इट इज नॉट देयर इन द बेसिस। बाकी तो सब सेम जैसा हमने हमने सिंप्लेक्स में किया है वैसे ही करते जाना है। जब तक zj माइनस cj पॉजिटिव या जीरो नहीं आते, कंटिन्यू दिस प्रोसीजर। So again, next our aim will be to make this 0, and this 0. So I'll write this table again in the next slide. This was the key element. Now make this element 0 by using the transformation R1 minus 2R2. To make this element 0, R3 plus R2. To make this element 0, R4 plus 6R2. We are using the transformations R1 minus 2R2, R3 plus R2, and R4 plus 6R2. Division A students, any doubt? Okay, hope there is no doubt. तो अभी हमको now tell me what will be the first row when I use the transformation R1 minus 2R2. First row, when I write R1, the R1 row will change. So what is the first one? R1, 0 minus 2 into 0. That is 0. Okay, पहले मैं वो R2 पहले लिख लेती हूँ. Then पहला एलिमेंट क्या होगा यहाँ पे 0 हो जाएगा. सेकेंड एलिमेंट क्या होगा? It is 1 minus 2 into minus 1 by 3. कितना हो जाएगा ये वाला एलिमेंट यहाँ पे? 1, R1 के बदले 1, minus 2 into R2 के बदले minus 1 by 3. So what will happen to this element? Just tell me this element. Division
1 by 3.
Huh? How much?
1 by 3.
1 by 3, is it so? 5 by 3. Division A, what is the value here? Anybody?
5 by 3.
5 by 3, ma'am.
5 by 3 है. Okay. How we get that? 1 plus 1, 2 by 3. तो इसको हमें -2 से मल्टीप्लाई करना, सब्ट्रैक्ट करना. तो 1 plus 2 by 3 will become 5 by 3. Okay. 5 by 3. नेक्स्ट तो 1 रहेगा. ये कितना हो जाएगा S2 वाला? -2 by 3. This one 0. How much is first BI? 24 minus 2 into 5. 24 minus 10, that is 14. Yes. Now write the third row. Third row में क्या होगा? R3 plus R2. So 1 plus 0, that is 1. 1 minus 1 by 3, 2 by 3. 0 minus 0, 0. 0 minus 1 by 0 plus 1 by 3, that is 1 by 3. Minus 1 plus 1, 0. 3 plus 5, that is 8. Then we have to have R4 plus 6R2. So again 0 plus 0, 0. 2 minus or 2 plus 6 into minus 1 by 3. क्या होगा यहाँ पे? 0. Then this is also 0. This will become 2 and this will become 0. So now we have, okay, now what will be the XB column? What is the XB column now? कौन-कौन से variables रहेंगे XB column में? See whether you are getting a unit matrix of order 3. S1, S2, S3 and X1. Okay. 1 0 0. 1 0 0 is corresponding to S1. तो मैंने यहाँ पे S1 लिख दिया. 0 1 0 is corresponding to S3. तो S3 लिख दिया. 0 0 1 is corresponding to X1. And also check whether you are getting 0 below these variable columns. x1 के नीचे 0 आना चाहिए, s1 के नीचे 0 और s3 के नीचे 0. दैट इज कंपल्सरी. बाकी 0 आ गया तो इट्स ओके, बट you have to get 0 0 for these basic variables, which means now we have got all zj minus cj's positive or 0, which means we have got the final solution. What is the, how to write the solution from the final table? What is the solution? All zj minus cj's are greater than or equal to 0. So how to write the solution? कैसे लिखना है? We had three variables in the two variables in the problem, x1 x2. What is the value of x1 from this table? कैसे लिखते हैं, याद है? x1 और यहाँ
ఏం
पे
ప్రాబ్లం
देखिए,
ఉంది పైల బట్టల్లో కరెంట్ వస్తలేదు
हाँ यस, x1 का
దాంట్లో
bi में
ర్యామ్
देखना है
ప్రాబ్లం
ट्रांस.
రాదు నైసెస్
हेलो
వైర్ ఖరాబ్ అయింది ఉంది వైర్
हेलो,
మళ్ళీ ఇంటికి తీసుకోమంటారు చేతి ఎత్తి ఈడ.
x1 is equal to 8. Now
అబ్బా.
x2 is not coming in the basis, which means that x2 will be equal to 0. And substituting x1 and x2 in the maximize z function, we will get 6x1 plus 4x2, that is equal to 48. 8 comma 0. Okay, we have to see whether the given variables, in the given problem we had only two variables x1 and x2, all these were added later on. Okay, we had only two variables given in the problem. So check whether those variables are there in the basis. If they are there in the basis, check the value of corresponding bi's. तो यहाँ पे खाली x1 का वेरिएबल है and we have got x1 is equal to 8, but x2 is not coming here, so it is equal to 0. ठीक है? Let's try one more problem. एक बार वो आर्टिफिशियल वेरिएबल का पार्ट निकल गया तो we don't have to bother. That is same as simplex method only. Only till m, when m is there, you have little bit of calculation part to calculate zj minus cj rho. Take the next problem. दैट इज बेटर बिकॉज एक्चुअली क्या होता है, बुक में ना दो मेथड्स दिए हैं. अगर मैक्सिमाइजेशन है तो माइनस एम करना है, और अगर मिनिमाइजेशन है तो प्लस एम करना है. तो आई एम नॉट गोइंग टू कंफ्यूज यू. एवरी टाइम यू ऐड माइनस एम ए ओनली. ओके, एंड विल कन्वर्ट एवरी प्रॉब्लम टू मैक्सिमाइजेशन. पर कंफ्यूजन ही नहीं चाहिए. तो बहुत कंफ्यूजन होता है कौन सा ऐड करना है. तो वी आर कन्वर्टिंग all the objective function to maximization and give the cost as minus m. Yes, you have to always add minus m a to the objective function. Okay. Next problem, minimize z equal to x1 plus 2x2 plus x3 subject to 2x1 plus x2 plus x3 less than or equal to 2, 3x1 plus 4x2 less than or plus 2x3 greater than or equal to 16, x1, x2, x3 greater than or equal to 0. Three variables are given and two constraints are given. Okay? इसको हम ऐसा इसको बोलते हैं नॉन नेगेटिविटी कंस्ट्रेंट. कंस्ट्रेंट्स आर ओनली दीज टू. तो दो कंस्ट्रेंट है और यहाँ पे तीन वेरिएबल्स दिए हुए हैं. Actually, you have done graphical method in 12th, but that is applicable only when you have two variables. When you have more than two variables, then these type of methods are used to solve an LPP. तो सबसे पहले हमको मिनिमाइजेशन को मैक्सिमाइजेशन में कन्वर्ट करना है. We have to convert the minimization to maximization. So we know that minimization is minus maximization of minus z. So we will not take this minus sign while solving the problem. We will take only maximization of minus z. ठीक है? And last में क्या करेंगे, यहाँ पे substitute कर लेंगे. We'll get the value of minimize z. We don't have to use this minus sign. This is the conversion part. But when you solve the problem, take only maximization of minus z, which can be taken as z star or something like that. तो ये माइनस साइन लेने की जरूरत नहीं है while solving the problem. तो इसको मैक्सिमाइजेशन करना है. फिर यहाँ पे कौन सा वेरिएबल ऐड होगा फर्स्ट कंस्ट्रेंट में? Which variable will be added in the first constraint? Slack variable, that is plus S1. Second greater than or equal to constraint hai, so we have to subtract a surplus variable and add an artificial variable in the second constraint. Okay, so I'll write this equation. पहले हमने जो हमारा minimize function था ना, we had minimize z equal to this. So I am considering maximization of minus z. Maximization of minus z मतलब z के बदले minus put करना है. We will get the maximization of minus z function. So I'll have minus x1 minus 2x2 minus x3. तो यहाँ पे s1, यहाँ पे minus s2 और a. First I'm writing it as minus z and then उसके बाद हमको slack variable add करना है, surplus variable subtract करना है, and once you subtract the surplus variable, add an artificial variable, give the cost as minus n, and the costs of s1, s2 are given as 0 in the objective function. And all the variables are greater than or equal to 0. Again, we'll write all the variables first. Writing all the variables, 3 variables x1, x2, x3 given in the problem. We have added s1, s2 and a. So writing those 3 also, and the right hand side is denoted by bi. फिर first constraint लेना है, so 2, 1, 1, 1, 0, 0 and 2. फिर यहाँ पे 3, 4, 2, 0. S1 is not there in the second constraint, so 0, S2 का -1, A का 1, and this is 16. दो ही constraint है, so we will have only 2 rows. Then we have to write Cj, coefficient of all these variables from the objective function. -1, -2, -1, 0, 0, minus m. नेक्स्ट इज XB कॉलम. कौन कौन से वेरिएबल्स XB में?
S1 and A.
S1 and A, correct. S1 and A. So S1 and A. S1 is corresponding to 1. There are two constraints. So we will have only 2 by 2 unit matrix. So 1, 0 and 0, 1 is A. The cost of these variables. S1 का cost 0 है. A का cost minus M है. So I've given minus M. Then writing Zj. जितने वेरिएबल्स हैं उस वेरिएबल्स को लिखना है. कंस्ट्रेंट में से वेरिएबल्स के कोएफिशिएंट्स, ऑब्जेक्टिव फंक्शन में से वेरिएबल्स के कोएफिशिएंट्स लिखना है. bi's are the right hand side. xb is the column which are there in the basis, or we say 1, 0, 0, 1 corresponds to whichever variable that has to be written over here, and then the cost of these variables has to be written over here. Now Zj. Zj कैसे निकालना है? 0 into 2 plus minus m into 3. 0 सिंप्लेक्स में सब कुछ 0 होता था, बट यहाँ पे बिग एम में 0 नहीं होता है. तो 0 into 2 plus minus m into 3. So minus 3m. 0 into 1 plus minus m into 4. Minus 4m. यहाँ पे ये पूरा टर्म खाली इसका पार्ट बचेगा. 2m. This is 0. This is m. This is minus m. Okay, Zj is 0 into 2 plus minus m into 3, that is minus 3m. Then second column के लिए 0 into 1 plus minus m into 4, that is minus 4m. 0 into 1 plus minus m into 2, that's minus 2m. Then we have the remaining numbers. CB is the cost. जो हमारे ऑब्जेक्टिव फंक्शन में जो हमने वैल्यूज दी हैं S1, S2 और A के लिए, जो भी वेरिएबल्स यहाँ पे हैं उसकी कॉस्ट को लिखना है. S1 को हमने 0 लिया है तो यहाँ पे 0 आएगा. A को हमने माइनस m लिया है तो यहाँ पे माइनस m आ जाएगा. दैट इज द CB कॉलम. ओके हर्ष? ओके. नाउ लास्ट विल बी Zj minus Cj. Zj minus Cj. Minus 3m plus 1. Minus 4m plus 2. Minus 2m plus 1. 0 minus 0, 0, m minus 0, m minus m, that is 0. अगेन 0 आ रहा है, चेक कर लो. There are two variables here, and corresponding to those two variables, Zj minus Cj has to be 0. Now tell me which one is the key column. कौन सा most negative number है? Which one is the most negative element here? Take m as 100. Take m as 100 and decide which one is the most. अगर मैंने m को 100 लिया तो यहाँ पे क्या आ जाएगा? -300 plus 1, that is -299. यहाँ पे हो जाएगा -400 plus 2, which is -398, और यहाँ पे हो जाएगा. तो which one is the maximum here? 4m plus 2. This becomes the key column. There are two positive elements. So take the ratios of these positive elements, 2 by 1, 16 by 4. 2 by 1 and 16 by 4. 2 is the minimum. So first row becomes the key row. And the intersection of key row and the key column is called as the key element. Okay? -4m plus 2 आएगा निकिता, not m1. Yes. Intersection of key column and key row is called as the key element. Key element is already 1, so we need not do it. Only thing, in the next step, you can cancel the Cj row, Cb column and Zj row, ratio row, and write the next table. तो बहुत कौन सा लेना है, बहुत कंफ्यूजन होता है इसके लिए. जस्ट राइट दैट. इट्स नॉट रिक्वायर्ड टू कैंसिल, बट आई फील दैट हमको जो चाहिए वही हम लोग रखते हैं. Only Zj is required in the beginning. After Zj is not required. So Zj row you can cancel, Cj row you can cancel, and Cb row and this ratio row. This is the column. This is the table which we get after deleting all those rows and columns which are not required in calculating the row transformations. So now, first element is 1. You have to make this element 0. So it will be R2 minus 4R1. इसको अगर 0 करना है तो R3 प्लस, इसका उल्टा यहाँ पे होना चाहिए, तो प्लस 4m minus 2 into R1 है ना. यहाँ पे -4m plus 2 है. अगर मैं इसको 4m minus 2 से मल्टीप्लाई करूंगी और ऐड करूंगी तो ये दोनों 0 हो जाएगा. So first row will remain as it is. Tell me what will be the second row. Second row में 3 minus 8 है ना. It is 3 minus 4 into 2. 3 minus 8.
-5.
5. 4 minus 4. 0. 2 minus 4. Minus 2. 0 minus 4. Minus 4. Minus 1 minus 0. This is also 1. 16 minus 2 into 4. That is 8. Careful in doing this calculation part, otherwise nothing is there. Now what is Zj minus Cj? Row. First यहाँ पे क्या आएगा? -3m plus 1 plus 4m minus 2 into 2. क्या बचता है? -3m, R3 के बदले -3m plus 1 प्लस ये वैसे ही रहेगा, R2 के बदले, R1 के बदले 2. So when you simplify that, what do we get? Just write in a paper and see what is the answer you get. Division A, you can unmute yourself and say what is the first number. -3m plus 1, 4m minus 2 into 2. Harsh is saying m minus 1. What about others? This plus 4m minus 2 into 2. I've got, I'm sorry, 5m minus 3 I've got. Is it okay? Or yeah, m minus 1?
5m minus 3.
हाँ
Right?
मैम.
5m minus 3?
हाँ.
Okay. Harsh has got m minus 1. ना? That is why. ठीक है. Second तो 0 हो जाएगा. Third में क्या आएगा? minus 2m plus 1 plus 4m minus 2 into 1. Yeah. थर्ड रो का लास्ट, थर्ड कॉलम का लास्ट में क्या आएगा?
2m minus 1.
2m minus 1. ओके, यस 2m minus 1. उसके बाद 4m minus 2, फिर m और फिर 0. ठीक है, होप दिस वैल्यूज आर राइट. R3 में जो भी वैल्यू है यहाँ पे सब्स्टिट्यूट करना है, दिस इनटू R1 में जो भी यहाँ पे पुट करना है, एंड कैलकुलेट द Zj minus Cj. तो XB में कौन कौन से हैं? 1 0 is corresponding to X2 and 0 1 is corresponding to A. Okay, so now we see that, now I told you m is very large, so 5m minus 3 is going to be a positive number. है ना, अगर मैंने m को 100 लिया तो 5m minus 3 is positive, 2m minus 1, everything is a positive number. All Zj minus Cj's are positive. Okay, all Zj minus Cj's are positive, but still m is there in the final answer. Okay, because when you have the value of A as something, then that is going to affect our objective function. So since all Zj minus Cj's are positive, but you are having m also in the last row, and the artificial variable is remaining in the basis. It is not moving outside this xb column. Okay, the artificial variable is remaining in the basis, and the value of artificial variable is equal to 8. अगर इसकी वैल्यू 0 आती है तो it has a solution. Here the value of A is equal to 8. So we say that since all Zj minus Cj is greater than or equal to 0, but artificial variable remains in the basis at non-zero level. मतलब A की value is not equal to 0. Artificial variable is there in the xb column, and the value of the artificial variable is equal to 8, which means that there is no feasible solution, and this solution is called as a pseudo optimum solution. Okay, so this solution, this type of solution where we have all Zj minus Cj is positive, and the value of, when you write the solution for this, you will get x2 equal to 2, but A is equal to 8, because in the objective function we have added minus ma. तो अगर हमारे पास a की कुछ वैल्यू है तो it is going to change the objective function. So in such cases, when Zj minus Cj's are positive and the value of A is not 0, we say that this solution is called as pseudo optimum solution. अगर suppose ये value अगर 0 है तो it has a proper solution. The problem नहीं है. We should not have the value of A in the final answer, because the objective function maximize Z or minimize Z will change accordingly. Okay, this has a pseudo optimum solution, or there is no feasible solution. So next problem I'll show you, when the value of A is equal to 0, how to write the solution and all those things. Plus when you have an equality constraint, how to. So we'll continue with this in the next lecture, the same big M method. Okay, there are 2 more types are there in this, different, what is that, the conditions. So first one we had a solution, second was a pseudo optimum solution. So we'll stop for today. See you in the next. Please, so many of you are not writing your attendance in the chat box. Please do it. So thank you. We'll continue in the next lecture. Please write your attendance. I'm finding very few students writing your attendance. So I'm marking them absent only then. Thank you. Thank you.